Today we are going to discuss on a hydrogen, a resource often hailed as a fuel of the future. And in present world, when we talk about emission suppression, basically iron and steel industry, cement industry, or petrochemicals, everywhere we are talking about hydrogen, and which act as a uh, breathing component, which can create a huge turnaround in CO2 emission. So, as far the emission reduction and sustainability is concerned, hydrogen is one of the most important pillar. So, while it has been a part of industrial processes for decades, we are now standing at a turning point where it becomes the primary pillar of a global energy transition that we have also seen its participation in various spheres of industries. So, to understand why it holds such a promise, we must first look at unique physical properties that make this element so special, so special. So, coming to and hence the universe's most abundant element is hydrogen, which is the lightest and the smallest molecule in existence. Yet it is the most abundant element in the universe. That is also a very, very big positive point. It is non-toxic and burns hotter and faster than natural gas, and remarkably producing zero carbon emission at the point of use. An exclusive way to think about it as a an energy sponge. It doesn't exist freely on the earth, and we must soak it up from water or fossil fuels and squeeze it out when we need power. However, the method we use to squeeze that energy out determine how clean the fuel actually is. So it all depend on the processing steps. So not all hydrogens is created equal. It is critical to recognize that hydrogen comes in a spectrum of colors based on its carbon footprint. Brown hydrogen from coal has a high carbon output, while grey hydrogen from natural gas is the most common today. We are moving towards blue hydrogen, which uses carbon capture, but the ultimate goal is green hydrogen, and which has a zero carbon output too, and is produced using only water and renewables. So let's take a close look at a specific magic behind that zero emission green hydrogen. So making green hydrogen, the as we know, its hydrogen is derived from the magic of electrolysis. The core of the green revolution is electrolyzer. Think of this as a reverse water fountain. Instead of mixing element, it uses a shock of clean renewable electricity to perfectly separate water S2O, that is S2O, into pure hydrogen and oxygen. The oxygen is simply vented back into the air, leaving us with a totally carbon free fuel. So once we have created this pure gas, the next challenge is how to hold onto the lightest, that is lightest substance known to man. So uh, holding onto the lightest gas, because hydrogen is so light, uh, mm, we have to use uh, advanced storage method, uh, to give it energy density. Currently, 80% of the storage is done as high pressure gas. Squeeze into tank at up to 350 bar, similar to a high-tech scuba tank. For more extreme needs like flight or space exploration, we use cryogenic liquids, chilling the gas to an incredible minus 253 degrees centigrade in what is essentially the world's most extreme thermos. So with this storage solution in the place, hydrogen is no longer just a laboratory concept. It's already on the move. So hydrogen on the if you talk about hydrogen, um, more movement of hydrogen is now actively replacing diesel and jet fuels in heavy duty transport, as we have also come across a lot of examples in our society and in different states too. So exclusive example of this is in action include Germany's Hydrail passengers train, as it's shown, uh, and hybrid Tiger UAV, which can achieve 48-hour continuous flight. And unlike heavy batteries, hydrogen provides the long range and rapid refueling necessary for major cities like London, Beijing, and Chicago to run successful hydrogen bus fleets. But hydrogen's impact goes far beyond just moving people. It's the missing puzzle piece for our most difficult industrial challenge. So decarbonizing the hard to abate sector is a really challenge. And there are industries where batteries simply are not powerful enough. These are the hard to abate sectors. Hydrogen provides the intense chemical heat needed for metals and refining. That is, we can say green steel, and serves as a critical feedstock for global fertilizers. Furthermore, it acts as a massive long duration battery for grid stability, storing excess wind and solar energy for which the weather is not cooperating. Despite these benefits, many people still ask the most important question: is it safe? So, we ourselves also ask that, is hydrogen safe? The elephant in the room, the industry recognizes that public trust is the top priority. Like gasoline, hydrogen is flammable. We know the challenge is it is invisible in daytime, but the sector refuses to leave safety to chance. By utilizing process safety management (PSM), a framework built on decades of chemical handling experiences, incidents remain incredibly rare. So we must balance the perception of the risk against the reality of modern engineering. Part of that reality is that hydrogen actually processes several built-in safety features provided by nature itself. So, features hydrogen has an escapes factors. It's a 3.6 times more diffusive than natural gas, meaning if a leak occurs, it rusts straight up and disperses instantly rather than pooling on the ground like gasoline vapors. Additionally, its flame produces low radiant heat, making it less likely to spread to nearby objects, and unlike oil spills, a hydrogen leak has zero toxicity to the local environment or water supply. We then take these natural advantages and reinforce them with many layers of high-tech defenses. So now, how we engineer safety in our modern facility. Uh, Safety is layered through four keys. We can say four key pillars. So one is the detection, that is like a sniffer sensors. Ventilation is one of the most important aspects. The active roof venting we can provide, and which can take control of this, control like automatic shut-off valves and materials. So we use a specialized non-combustible material specifically designed to prevent hydrogen embrittlement, which is where metal could otherwise weaken from the long-term exposure. So when you combine these safety layers with the renewable production, you get a complete, full, sustainable loop. So the complete cycle. Let us discuss about the complete cycle. A zero carbon, a basically zero carbon ecosystem. What is this? So this is the zero carbon, a perfect closed loop system where we use natural energy to split water, store that energy safely, use it to power our heaviest industry, and then in a beautiful bit of chemistry, the only byproduct released back into air is pure water vapor. It is the ultimate circular economy. So, as we conclude, let's look at the three pillars that define the future of this industry. And to summarize, we can say hydrogen is essential, scalable, and safe. So, it is the missing link for decarbonizing where batteries fall short, and the technology is ready now. Global electrolyzer capacity is projected to reach 125 gigawatt per year by 2030. Combined with uncompromising safety standard, it is as safe as, if not safer than, the legacy fuel we rely on today.